All right, take a look around you for a second. That window frame, the metal fins cooling your computer, even key parts of your car. They're all these really complex metal shapes. Today, we're going to pull back the curtain on the incredible engineering process that actually creates them.
So, yeah, have you ever actually wondered how that happens? I mean, how do you get from a simple, boring block of aluminum to something as intricate as a window frame or a high-tech heatsink? It kind of feels like magic, right? But nope, it's just some seriously powerful engineering. Well, the secret is a process called extrusion. And honestly, the absolute best way to picture it is to think back to playing with Play-Doh. Remember that little press thingy? You'd stuff the Play-Doh in, push down, and out would come a long star or a spaghetti shape. Extrusion is basically that, but it's a super-powered industrial version for solid metal. Simple idea, right? But trust me, when you're working with metal, things get way, way more intense.
Okay, so let's dive into the art of extrusion. And to get started, we need to meet the hero of our story, the aluminum billet.
So here it is. Our journey starts with this, a solid, kind of plain-looking cylinder of raw aluminum. This is what we call a billet. And yeah, it might not look like much, but its destiny is to be totally transformed. This one block holds the potential to become all sorts of things, what engineers call sections. The finished shapes that are literally all around us. But, this transformation, it's not a walk in the park. Our billet is about to go through some serious trials. We're talking extreme heat and incredible force. It's time to put it under pressure. Okay, so the ordeal starts with a whole lot of heat. First, we have to get that billet super hot, over 450 degrees Celsius, which is like 850 Fahrenheit. Hot enough to make solid aluminum soft and workable. Then, a special lubricant, a release agent, is put on it so it doesn't get stuck. And finally, this glowing, softened billet gets loaded into a massive, thick-walled steel container. It's all prepped and ready for the main event. And here's where things get real. A powerful hydraulic press pushes a ram against the billet with just immense force. We're talking thousands of tons of pressure. It's an absolutely incredible amount of power, all focused on one goal, forcing that softened metal to go exactly where we want it to.
So all that heat, all that pressure, it's all been building up to this. This is the moment of transformation. It's time for forging the final shape.
And what does it turn into? Well, you basically get two main types of shapes, or profiles. You can have a solid profile. Think of a single heat sink fin. It's just one solid piece. Or you can get a hollow profile, which is a shape with one or more empty spaces inside, like a square tube or, a really complex window frame. And let me tell you, the engineering that goes into making those hollow shapes is seriously clever stuff. The key to this whole transformation, the thing that decides the final shape, is the die. You can think of it as the gatekeeper. It's this super hardened steel tool, basically a thick disc with a very specific shape cut out of it. So when that ram pushes the billet forward, the soft aluminum has no choice but to squeeze through that opening. And what comes out the other side? A long, perfect, continuous profile, a section that exactly matches the shape of the die. Of course, every hero's journey has its obstacles, right? And in this story, the big challenge is something called die wear. All that intense pressure and incredible heat, slowly but surely, starts to wear away at the steel die. It's like erosion. And this is a huge deal, because even a tiny bit of wear can mess with the precision of the final shape. So engineers are always in this constant battle, trying to manage and predict die wear to make sure everything stays perfect.
Okay, so our shape has emerged from the die, but we're not done yet, not by a long shot. The new profile is still super hot, and it's not always perfectly straight. So now it's time to refine it, to make it straight, strong, and precise.
This finishing process happens in a few key stages. First up is stretching. The long piece of aluminum is gripped on both ends and pulled just a little bit. This is super important because it gets rid of any small twists that might have happened when it came out of the press. Next, it's straightened to make sure it meets the exact, precise measurements. And then finally, and this part is absolutely crucial, it goes through something called aging. This is a special heat treatment that actually hardens the aluminum, giving it its final strength. And this final level of hardness and strength has a name. It's called its temper. A great way to think about it is like stats for a character in a video game, like strength or durability. By using different aging processes, engineers can create different tempers. So one temper might make the aluminum super, super strong, while another might make it a bit more flexible. The temper tells you exactly how that piece of metal is spec'd out to perform its job.
And when we talk about precision, it really, really matters. We measure it in a couple of key ways. First, there's tolerance. This is how much the final piece is allowed to differ from the perfect design. And we're talking tiny amounts, often just fractions of a millimeter. It has to be that exact. Then you've got the surface finish. This is all about the quality and the texture of the surface itself. Sometimes it's just about looking good, but for many applications, the right surface finish is absolutely critical for the part to work correctly.
So, our billet has gone through its epic journey. It's been heated up, squeezed, and totally transformed. But what about the leftovers? The bits that didn't make it into the final product? Well, this is where the process gets really, really smart. Because in modern aluminum extrusion, nothing is wasted.
So how efficient are we talking? Well, a huge chunk of that original billet, about 85%, becomes the final usable product, which is great. But that still leaves, another 15%. So where does that go? That last little bit is made up of a few different things. You've got the butt, which is a small piece of the billet at the very end that just can't be pushed through the die. Then there's the back end of the extruded piece, which sometimes isn't perfect. And of course, there's any leftover scrap from trimming and finishing. But here's the beautiful part, the material recovery. All of this stuff is 100% recyclable. It all gets collected, melted back down, and made into brand new billets. The process just starts all over again. It's a completely closed, sustainable loop. If you really want to get a sense of just how dramatic this transformation is, there's a number for that. It's called the extrusion ratio. Basically, it's the ratio of the billet's starting area compared to the final shape's area. And these ratios can get pretty wild. You could have an extrusion ratio of 100 to 1. Just think about that. It means the material has been squeezed down until its cross-section is only 1% of what it started as. It's a fantastic way to grasp just how much the metal gets reshaped. So there it is, the secret life of metal shapes. We start with a simple block, and through an incredible journey of heat, pressure, and precision, it becomes something completely new. What we get at the end is a material that's strong, light, incredibly precise, and, this is huge, endlessly recyclable. It's an amazing technology. So the only real question left is, what are we going to build with it next?